Well, good morning. Happy New Year to you. If you're like me, woke up this morning, noticed the weather forecast through the southern plains and the Gulf states. I'm sure you noticed that there's going to be quite a bit of unsettled weather for the next 48 hours or so across Texas and much of the Gulf Coast, Louisiana, Mississippi, Alabama, Florida Panhandle. And that's not necessarily typical this time of year, January, 1st of January. It's not unheard of. Back in 2015, we noted a tornadic outbreak through Dallas and much of East Texas the day after Christmas. So it's not unheard of to see this, but this is usually something we talk about more in the springtime or even in the fall, but not really the dead of winter. So I'm going to walk through this a little bit and try to understand better what kind of weather we're going to experience and what kind of coverage we're going to get and what kind of intensity we can think about. Well, we'll give it our best shot. Let's get started. Well, the first thing I'm going to look at when we're talking about convective weather is the Storm Prediction Center's outlook. Now, the Storm Prediction Center is headquartered in Norman, Oklahoma, and they're the authoritative source for the National Weather Service when it comes down to severe weather, whether it be tornadoes or thunderstorms, severe thunderstorms, hailstorms, anything like that. Now, when we see these forecasts, we have to understand that this is the worst case scenario for the next 24 hours. So this first chart that we're looking at is a thunderstorm forecast, and the darker the colors get, or excuse me, the more potent the colors get, the more potent the storm's potential gets. But this is valid for the next 24 hours. This starts at about sunrise this morning, being New Year's Day, till about sunrise tomorrow morning. It's actually from 12 Zulu to the next day at 12 Zulu when we're talking about time frames. But anyway, basically from sunrise to sunrise, and we can see that Central Texas is under the highest threat. At least here on New Year's Day for severe weather. When we're talking about slight, that yellow circle through Hill Country, Big Country, I-35 corridor, the Texas Triangle, all the way over to Houston. That's what we're talking about. Few to scattered thunderstorms that could be severe throughout that area. Now we see that other darker green through there. That's marginal. Certainly a chance for some organized severe weather through there as well, but it's a little more isolated in nature, while the light green is just generic thunderstorms in general. Now we can also move ahead to day 2. Now day 2 starts at sunrise on Monday, 12 Zulu on Monday, and goes through 12 Zulu on Tuesday, which is about sunrise on Tuesday morning. And we can see that this whole complex of forecasted severe weather has moved east. We would expect that to happen, generally happens that way. And we can see even more potent colors appear here. We've introduced the enhanced region through Louisiana, through Mississippi, through Alabama. This region is definitely scattered severe weather. Most storms that would occur through this area of enhanced would probably carry a good chance of being severe. Now, when we're talking about severe, we're talking about they could have large hail. They could have strong wind gusts, upwards of about 50 miles, 60 miles an hour or so, and they could have tornadoes with them. The fact that the Storm Prediction Center has highlighted the Gulf Coast there for enhanced severe weather on a day 2 forecast, so we're talking at least 24 hours out, is pretty significant. It's not unheard of. I've certainly seen it in the past, but the fact that there's such high confidence for severe weather to be occurring through New Orleans, Jackson, Mississippi, Biloxi, Gulfport, Mississippi, all the way over to Mobile, even Montgomery, Pensacola, that area, 24 hours to 48 hours in advance says there's really high confidence that there's going to be some pretty nasty weather happening through there. So that's what we're going to do, is we're going to dive into this and see what kind of truth there is to that. Okay, so the first thing that I'm going to look at when I actually want to dive into a weather forecast, instead of just taking somebody else's word for it, I want to dive in. I want to really see what kind of weather we can expect. But I can't do that until I get a good idea of what's currently going on. Really, what's happened in the past few hours and what's currently going on. I can't accurately predict the future unless I have a good baseline to start from. And so that's what I'm doing here with the water vapor satellite image, is I get a very good idea with this satellite image of where the jet stream is, where our storms are, where our wind is flowing, and where our energy within the atmosphere is. And one big thing that I can really pick out just immediately by looking at this water vapor image loop, really there's two things. The first one is I can get a good picture of where the jet stream is. And if you've noticed, there's what we call troughing, deep troughing, that's coming off of the coast of California. It's dipping down into mainland Mexico, and then it's moving up through the state of Texas and into the Midwest. And it's ridging through the Midwest. So that's one thing I can look at. That's the southern branch of the polar jet. Then the other thing that I notice on here is it's kind of subtle, but you can notice over the panhandle of Texas and then out through the panhandle of Oklahoma and Kansas, you can see some rotation within the moisture fields out over there. Now that's a pretty subtle shortwave trough over there, but that brings some energy to the region. So that's another thing I noticed. Same thing can be noted over Southern California, entering Arizona. There's also some rotation in the moisture field out over there. And that's really the one I'm going to be paying a lot of attention to here through the Central Plains and, the Southern Plains and the Gulf Coast states, because there's a lot of energy within that particular rotation field, and it's moving our direction. So that kind of sets the baseline of, okay, well, here's where we're at now. We're not experiencing any severe weather now, but those features are going to be progressing our direction, and those are going to be our weather makers. So those are the features that I need to continue to watch if I'm going to begin a forecast for severe weather. Now, there's a lot of great analysis products that we can use to really build a good foundation for our forecast to set itself on. I could go on for hours about those, but I'm actually just going to go ahead and jump straight into the forecast, and then I'll get to those analysis products in due time, probably in different videos. First thing I'm going to look at is computer-generated forecast models. This one being the North American model. It's called the NAM. It is used by the National Weather Service, and it usually does pretty good job for the next couple of days or so. But I want to identify a couple of things on here to make sure that this forecast model is an okay forecast model to use. Sometimes it's not. We've got to identify that it actually started off on the right foot. If this forecast model is computer generated, if it didn't start off on the right foot, then it's not going to lead us to the right conclusion when it comes down to our weather forecast. So we have to do our due diligence before we even start our weather forecast to identify what's currently going on in the atmosphere and how our forecast models are lining up with that. If there's a bias in the forecast model or the forecast model is wrong, we need to make those adjustments, or maybe just not even use that model and use some other model. Whatever the case, each forecaster has their different method of doing it. There's no right or wrong way to do it, so long as that we're making the adjustments that we feel are necessary to those forecast models. But looking at this North American model, it seems like it's doing an okay job. There's I see a couple subtle little differences, but in the grand scheme of things, it looks like it's doing okay. We noticed some rotation there through the state of Colorado and Kansas, kind of like we saw in that moisture field and the satellite image. Same thing down through California and Arizona. We see some rotation in the wind speeds and wind barbs through there. And then we also see the deep troughing of the southern branch of the polar jet going through northern Mexico and then ejecting out through Texas and into the Midwest. So overall, it's lining up all right. I'm going to go ahead and use this one just for the sake of time. And ordinarily, I would use several of these different forecast models and try to come to a consensus with them. But I'm going to go ahead and use this one for the sake of the video, and it'll do the job just fine. Now we notice that as we progress through time, that troughing, that rotation through Arizona and California starts to deepen a little bit as it progresses eastward. Okay, and then we notice that as it impacts Texas and then starts to move through the Gulf states, it kind of reorients itself just a little bit, where the base of that trough is kind of like a dip, the dip in the road, where the base of it actually is a little bit farther east than the head of it, and that's what we call negative tilting of a trough. So that's really something that we have to pay attention to, especially up here at the jet stream level for severe weather. Anytime I see any sort of negative tilt to a trough, especially at the jet stream level, that's something I really got to pay attention to. Simply for the fact it's known to create a lot of instability within the atmosphere, and instability is exactly what fuels thunderstorms and severe weather. So the reason we're looking at the jet stream first is because most severe weather is driven, at least organized severe weather is severe thunderstorms are driven by the jet stream. You generally won't see organized tornadic outbreaks or organized large hailstorms, supercell complexes, or anything like that, unless you have some sort of jet stream that's driving it. Certainly you can get severe weather without the jet stream, but in this case, where we're talking about several days of organized severe weather, the jet stream is going to be playing a large role in that, and that's exactly what we see. We already see that negative tilting all the way up at 300 millibars. The next thing I'm going to look at is down at a pressure level called 500 millibars, and that's typically about 18 to 20,000 feet in the atmosphere. It certainly varies, but it's what you would consider the middle of the troposphere. Typically, it's about halfway between sea level and the stratosphere. So, and the reason that we look at this specific level is this: we can usually pick out the subtle waves of energy, and sometimes that's all it takes is a very subtle wave of energy that will drive severe weather. And that's exactly what we're going to see here in this particular image loop. Is through the state of Texas, we see that bump in the road, that little dip in the road, through the state of Texas and ejecting out through the Gulf states up all the way through Tennessee and even Kentucky. And this specific image, the color on it, indicates vertical velocity, and all that's saying is that there's a lot of lifting motion within the atmosphere, and at least in this level, and that's important for us when we're talking about thunderstorms. Thunderstorms are very, very heavy features. Just think of all the rain and all of the hailstones and all the energy within that thunderstorm, and just all that moisture in it can often weigh over 1 million pounds, and some thunderstorm complexes they can take up half of a state, probably not the state of Texas, but half of a smaller state for sure. Think of all the weight that is suspended in the atmosphere. So we need a lot of atmospheric lift to keep all of that suspended. Also, to grow these thunderstorms, these thunderstorms get their moisture, in this case, largely from the Gulf of Mexico, which is at sea level. So we need to not only bring this moisture inland, but then we need to lift this moisture all the way up to 30,000, 40,000, 50,000 feet in some cases. And that's what creates our severe weather. So when we're looking at vertical velocity, we can see, okay, here's our atmospheric lift, and certainly we see when we're starting to see that yellow and red and blues and deep colors, we got plenty of lift that we would need for some sort of severe weather to occur throughout the next couple of days. Well, there's a lot of products I can go through that meteorologists would look at when they're creating severe weather forecasts, and I'm going to spare you the trouble, and I don't want to bore you, so I'll certainly get to those probably in other videos and so forth. But I'm going to walk through a couple more products that are pertinent to this specific severe weather outbreak, and one of those is dew point, surface dew point. Dew point is often misunderstood by the general public. People understand temperature and think they understand relative humidity, but dew point is fascinating because dew point tells us exactly how much moisture is in the atmosphere. We would think that relative humidity does that, and certainly relative humidity speaks to the amount of humidity in the atmosphere, but not necessarily the amount of moisture content within the atmosphere. So that's what dew point does. And one of the things that we notice as we scroll through time and throughout the next couple of days is high dew point values throughout the Gulf states, and upwards of about 60 degrees Fahrenheit. And that is a lot of moisture. Certainly it's not scorching hot this time of year, so we can assume that the relative humidity is pretty high through that area as well. But all that moisture, 60 degrees Fahrenheit of dew point, combined with that lifting motion that we saw from the 500 millibar pressure level, that's a lot of moisture with a lot of lift, creates a lot of cloud. And certainly with the instability that's also in the atmosphere that we noted with that negatively tilted troughing, we can get some pretty good thunderstorms out of those. And so this is something else that I can guarantee the folks over at the Storm Prediction Center have looked at and have decided on a severe weather forecast. Now, one thing that we have to look at when we're talking about any sort of thunderstorms, whether they're just ordinary thunderstorms or we're talking a severe weather outbreak, is instability within the atmosphere. And I spoke to instability a little bit when I was talking about in the upper levels, when I was talking about negative troughing and how that promotes instability and so forth. But I'll try to explain instability a little bit better to you so you get a better understanding of what exactly we're talking about and why it's so important for thunderstorm development. We won't see thunderstorms. In fact, thunderstorms are impossible without some sort of instability within the atmosphere. So what instability is, the best way to explain it is if you were to hop in an airplane and you were to take that airplane up to 20,000 feet or 30,000 feet, you would notice that it's much cooler in the atmosphere up there. And the reason for that is that the atmosphere cools with altitude at a certain rate. Generally, that rate is tied to how moist or how dry the atmosphere is, but it's not going to get warmer with height until you hit the stratosphere, at least. It's not going to get warmer with height. It's going to get colder with height. Now, when the atmosphere cools faster than it's supposed to, that creates a void within that portion of the atmosphere. All of a sudden, we've got air that's cooling way faster than it should be cooling. And it leaves a little bit of a void there that has to be filled with something. And in this case, we're going to see that void is going to be filled with all of that moisture. We've already got lift in the atmosphere. We've already got a ton of moisture in the atmosphere, as we've already seen. And in order to fill that void, the atmosphere is going to lift that moisture and it's going to put it into that void, and it's going to try to equalize it. That's what the atmosphere is trying to do. It doesn't want to be unstable. It wants everything to be in equilibrium. So it's going to try to fill that void. The way to best fill that void in this case is to lift all that moisture up into that level of instability. And that's how we see thunderstorm development. And that's why when we see thunderstorms develop, a lot of times they can happen very, very quickly. They can, especially in the desert where I'm from originally, we would see thunderstorms, just giant thunderstorm clouds, build within 30 or 45 minutes, and then they would collapse very quickly too. So within an hour and a half, sometimes we would get a giant thunderstorm, and then it wouldn't be there anymore. And what happened to it? So this development, especially when the atmosphere is very unstable, can happen very, very, very quickly. Now we can look at different portions of unstable layers and so forth, whether we're going to look at instability from the perspective of the surface versus instability from the perspective of the entire column versus most unstable layers and so forth. What I like to look at is, the maximum instability that we're going to see. And I'm going to relate that to not only the instability within the atmosphere, but we're going to relate it to the wind shear within the atmosphere as well. And the reason being is because if all of the wind throughout the column of the atmosphere, basically from, we'll just say the surface all the way up to 30,000 feet, if all the wind is exactly the same, we're not going to see a big separation between lifting and sinking motions within the atmosphere. We're not going to see a lot of rotation within any sort of storm. And that's good if you don't want severe weather. Certainly I don't think anybody wants severe weather. So if you don't see a whole lot of wind shear within the atmosphere, it's going to be difficult to get any sort of organized severe weather. Now, if we see some significant wind shear within the atmosphere, we can say, oh, okay, this storm is probably going to be tilted a little bit, and that separates the updraft and the downdraft regions within the storm. That promotes hail development, for instance. It circulates the storm. In fact, supercell thunderstorms, which can produce tornadoes, are generally rotating in nature, and that's why tornadoes can be very, very violent. Very much a highly sheared environment, which would promote tornadoes. So when we're looking for severe weather, I'm going to say, hey, well, we need this moisture, we not only need this instability, we not only need lifting motion, but really to promote organized severe weather, we're also going to need a decent amount of wind shear. And this specific image, courtesy of the College of DuPage, shows that there is a decent amount of wind shear within the atmosphere, and there's a little bit of instability there. There's not a significant amount of instability. When we're looking at parts of Texas, we can see about along the coast maybe 3,000 joules per kilogram. That's quite a bit of instability, but inland we don't see quite as much. Max of about 2,000. That's still significant, especially into wintertime, to see that sort of instability. And then as we move toward the Gulf states, we don't see nearly that much, about 1,000 joules per kilogram or so. So it's not super significant, but being that it is wintertime storms don't need as much instability as, say, a late spring storm would need to be violent. So anytime we're looking at about 1,000 joules per kilogram or more, at least through this part of the United States, we can start to be somewhat concerned about severe weather, especially if it ties in well with some strong wind shear in the environment. Now, I just got through talking about the strong wind shear and instability that's needed in the atmosphere in order to promote severe thunderstorm development and tornadic development. This is another forecast product that's derived from those characteristics, and this is called the Supercell Composite. So what this does is it just basically looks at the wind shear within the column of air and says, okay, there's strong enough shear here in order to promote supercell thunderstorms. Now remember, supercell thunderstorms are very large thunderstorms. They are rotating thunderstorms. They do produce tornadoes, not all of them certainly, but they do produce tornadoes. They can include large hail because of their nature. So we can see through East Texas, especially over closer to Houston and that area, and then through much of the state of Louisiana, Mississippi, Alabama, as we move through time, that there's definitely some color through there. Certainly the brighter colors are more to worry about, but even when we see the yellow or even the green, hey, there's definitely some potential there for some supercell development, and that's something we need to keep our eyes open for. So we were talking about moisture a while back, and another interesting forecast product that I do like to look at when we're talking about, well, we're going to get thunderstorms. Some of them are probably going to be severe thunderstorms. Some of them may even include tornadoes. But let's talk about heavy rain. Let's talk about flash flooding. And that's actually the hidden threat within these thunderstorms. A lot of people think, oh no, hailstorm, oh no, tornado, and those are certainly very dangerous, and proper precautions should be taken, certainly. But flash flooding is, in my opinion, even more of a widespread danger. While people can be killed by hailstorms and certainly by tornadoes, flash flooding is something that sneaks up on folks, and that can actually occur miles away from a thunderstorm, and be very, very destructive. In fact, flash flooding kills more people across the United States on an annual basis than tornadoes or hailstorms or anything like that. So when we're talking about whether we're going to see heavy rain and flash flooding, one thing that we need to look at is what we call precipitable water. And this is the amount of moisture through the entire column of water, basically through the entire atmosphere. So if you were to think of the atmosphere like a sponge, and you were to just squeeze all the water out of that sponge, all the water out of that atmosphere at any given point, and then you were to total that all up, that would be your total precipitable water. Okay. Now there are climatological values associated with precipitable water. So certainly in the tropics, there is more moisture within the column than there is in the desert. So the tropical air, when we see high precipitable water there, may not mean as much to us as if we saw it, say, through the Great Basin in western United States. But typically when we see anything over about 2 inches or so, and even this time of year, really anything over about 1.8 inches or so through the southeast, especially over land, anytime we see that, we can start to be a little bit concerned about, okay, we may have a heavy rain, flash flooding potential, especially if we get some strong thunderstorms develop, and we're talking about rain rates for several minutes, upwards of a half hour, maybe even more than that, of several inches per hour. We need to be concerned about these flash flooding. So we can see that as we progress through time. Not so much in the state of Texas. May see some floods through the state of Texas, but really the big talk is going to be the Gulf states. Alabama looks pretty hot there, but certainly Mississippi and Tennessee, all the way up really into Ohio River Valley, and then progressing into Georgia and out the eastern seaboard. So something that a lot of folks don't necessarily think about when we think about severe thunderstorms. It's kind of an afterthought, but unfortunately those can be just as dangerous, if not more dangerous, than a thunderstorm themselves. Now, this is the part where you say, oh, well, Dan, you could have just showed me this from the beginning and we would have been all good. You didn't have to show me everything that you showed me in this video, and waste my time with it. And I certainly hope you don't think this was a waste of time. I'm sure you wouldn't be watching if you still did. But this is the forecasted radar reflectivity. This is the computer model saying, this is what the radar screen is going to show as we progress through time. And this is definitely something that can be very, very useful, but it also can be misused. And the reason I didn't jump straight to this and call it good was because I want to understand what's going to be going on in the atmosphere. I want to understand what's going to be causing these storms. I don't want to just take the easy way out and say, oh, well, here's where the rain's going to be, here's where the thunderstorm's going to be, and okay, let's move on next, And no, I want to see what's going to be going on in the atmosphere. I want to see what's going to be driving the storms that we're expecting in the next 48 hours or so. So the thing that I noticed here is, well, we see some of that scattered storm development through central and east Texas, kind of like we had discussed before, and then we start to see as those storms begin to move east, they become a lot more widespread, and this aligns well with where the negative tilting of that upper level trough that we spoke of was. It also aligns very well with the higher dew point values through the Gulf states. It also aligns well through the total precipitable water. And we can see that there's just a large complex of storms that develop all the way from the panhandle of Florida all the way up into the Ohio River Valley come Monday evening. And that's largely due to the extra moisture content within the atmosphere, that strong lift that's keeping all that moisture suspended. So pretty cool product, something to kind of verify what we looked at and all the other dynamic profiles that we saw here earlier in the video, but this kind of just verifies that, okay, yeah, it certainly looks as though the Storm Prediction Center has forecasted this accurately, and it shows us places that are not going to be so great here in the next 48 hours or so. Well, that's it. That's all I have for y'all today regarding this outbreak of thunderstorms. And I certainly hope that if you're within this area highlighted, that you're safe and park your car in a garage and stay tuned to the National Weather Service threats. Or the Weather Channel, or your favorite source that you really like, and you keep track of how this is all going. If you do me a favor, go ahead and follow this page, like me on Facebook, or something to just let me know that, hey, this is something useful, something that you like, and I'll continue to do this as time progresses. So with that being said, have a great day.